What's up? What's up? What's up? It's your boy, the network. And today's topic is section 3.26b, OSPF area types. Backbone, normal, transit, stub, NSSA, and totally stub. Yes, those are some weird names, but Cisco came up with it. You know how they talk over there in California. Totally, dude. This is a topic in the CCNP route exam code 300-101, version 2.0. It is going to be known as the CCNP Enterprise exam come February 24th, 2020. So make sure you're studying for the correct material. Most likely this stuff will transition into the new test. Let's go ahead and take a look at the exam blueprint, see where we came from and where we're headed. This is the exam blueprint, implemented Cisco IP routing. It's also known as CCNP route exam. The section that we just wrapped up a video ago was the OSPF LSA types. Now that we've discussed OSPF LSA types, today we're going to discuss the area types. This is one of the confusing part of the exams as well, as what I've heard. And after that, we are going to cover the types of OSPF routers. What are the area types? First of all, what is an area? We know that OSPF is divided into several areas, right? When you are designing a network, most likely when you start out with the first area, which is called the backbone, as you can see right here. These are all the rest of the types of the area types. But anyways, OSPF is designed in areas, right? And there's different types of areas, as you can foreshadow from this bullet point. Let's go ahead and bring up those slides and talk about what each one of these area types are. The first one, as I've mentioned before, the backbone area. This area is also known as Area 0, or it's Area 0, which is also known as the backbone. All areas must connect to this backbone area. So if you look at this topology right here, we've got Area 0 right here in the middle, right? Obviously, we've got Area 1 connected to it, Area 2 connected to it. If we had a 3 right here, fine. We had a 4 right here, they're all connected to the backbone area. This is what an OSPF topology starts out with, the backbone, Area 0. Then there's the normal standard areas. Guess what those are? The other areas that are not 0 or not the backbone. So in this case, if you look at this topology, Area 1 is a normal or standard area. Area 2 is a normal or standard area. Any non-backbone area is considered a standard area. The link state database, as you can see, contains internal and external routes. Transit areas. Now, this goes hand in hand with the section virtual links, which will be about 2 videos after this, right? So a transit area, if you look at this topology right here, there's Area 0, right? What do we know? What is that known as? The backbone area, right? We also got Area 1 right here. But also we've got, notice how Area 2 is right here. What do we say about the backbone area or Area 0? All areas must connect to the backbone, right? Well, if you look at this, Area 2 is not connected to the backbone. In order for him to get to the backbone, he needs a transit area to get to the backbone, Area 0. So in this case, Area 1, which sits between Area 0 and Area 2. Area 1 would be called the transit area. This goes hand in hand with, again, virtual link. We'll talk about that in the next couple of videos. Again, it's an area that connects the backbone area to another area. Now, here's where the trickier area types come in. A stub area. We talked about what a stub is when it comes to EIGRP. Well, the same concept kind of lies here. We kind of create a dead end to the network when we cut off certain routes to come into it, right? So a stub area, when we declare an area a stub, it will filter type 5 LSAs. What's a type 5 LSA? It's an external route, I believe. Yeah, it's an external route. We talked about that in the last video, right? So when we declare an area a stub, it'll stop area type 5 LSAs from coming in. But notice it'll also stop type 4s, LSA type 4s from coming in. So those are routes that we're cutting off. Why do we do this, you would wonder? Why would we not want to know about? So there's certain routes that we might not even know about, or we just want to minimize our routing table. Because remember, every time we have these routes coming in and we need to try to figure out the best way to get somewhere, SPF, or shortest path first, that's the algorithm that OSPF uses to calculate these routes. Well, if we have so many routes to calculate, we're going to just use up our CPU, and it'll just be like, too much to calculate. And we don't want that. So that's why we try to minimize our routes by creating stubs. And that's the purpose of a stub area. This is how we configure it. We do area, the area number, and then we do stub. That is how, but you have to do that on each router. We'll talk about that in a little bit as well. Totally stubby areas. Yes, what were the guys at Cisco's marketing team thinking when they named the totally stubby area? Well, what's a totally stubby area? It's similar to a stub area, as you can see here, but it also filters type 3 LSAs. What's a type 3 LSA, right? It's a summary LSA, right? That's why we did the LSA types first. So if you don't know what the different LSA types, go to the last video and you'll know what those are. Again, it's an area summary LSA type. It technically allows one type 3 LSA for the default route. So the default route will be injected when we create a totally stubby area. So if you look at this route right here, it's topology right here, area 5 and area 0, right? Area 0 is the backbone, right? Area 5 is a totally stubby area. We have type 1s and 2s that stay within the area, right? Then we have type 1s and 2s that are also in the totally stubby area. But if we have some external routes coming in, and we name this a totally stubby area, it's going to, as you can see here, remove type 3, type 4, and type 5 LSAs. So that's a whole bunch of routes that we're going to remove depending on how many routes we have in our routing table that we will remove with that by creating this a totally stubby area. And then it'll inject what's called the default route. You know what a default route is, right? We did a video on that too. Go in the CCNP playlist, you'll see that. It'll inject the default route. That way you know these routers in here know how to get out of the area if they need to. So the default route will be injected into area 5, and that's how they get out. This is how you configure a totally stubby area. You do area number, and then stub, and then you just add the no summary keyword to it. That, again, has to be done on all routers in the area if you're going to make it a totally stubby area. Or not all routers, but all interfaces in that area. That's more specific. What's a not so stubby area? I would love to meet with the people in the Cisco's R&D department when they thought of these names. Not so stubby area is similar to a stub, but it allows redistribution via an ASBR. We know what an ASBR is, right? Autonomous System Boundary Router. You look at this topology right here. We got router 1, router 2, and router 3, right? We got area 0 right here between router 1 and 2, and then area 1 between router 2 and 3. This is the not so stubby area. Well, what's a not so stubby area? It's the same thing as a stub, right? What does stub do? Stops type 5s coming in, and it stops type 5s from coming in, right? So what if we have redistribution, right? What if we have an ELGRP domain right here, and we get a route into our not so stubby area? Well, we have a type 7 that's coming in, right? But remember, type 7s can't go into other areas. So we would have to turn that into a type 5. That's what a not so stubby area do. It allows the redistribution to come in, right? And allows the routes to come in, and then we generate type 7s in here. But if we needed to go to other areas, that route, then we need to change it into a type 5. That's what not so stubby areas allow. As you can see here, distributed routes will use a type 7 LSA since type 5s are filtered. And the LSDB, link state database, contains internal routes, summary routes, type 7, and a default route. So default route also gets injected into this as well. We configure it by using area, the area number, and then NSSA. We did this in the last video, in fact, so we can generate type 7 LSAs. That's what we did. Look at that video. That video prior to this is very important if you stumbled upon this. So you really need to watch that one. Totally not so stubby area. Yes, Cisco named this area a totally not so stubby area. What's that? A totally not so stubby area, similar to an NSSA, not so stubby area, but also filters type 3 routes and does not inject the default route. So how do you get out then is what you were wondering, right? Well, you look at this topology right here. We got area 0 right here, right? Area 12 is a totally NSSA, right? We declared it by making this interface totally NSSA, and this one totally NSSA. Now it's similar, but it just also filters type 3 routes. So we still, if we need to get to, let's say, okay, yeah, so type 7s and the default route. That's my bad. The default route does get injected to it, and that's what the link state database will include: the internal routes, type 7, and the default route. So we configure it by making the area border router. We do area, the area number, NSSA, and then no summary. That is how we configure it, like this right here. But remember, this one is an NSSA, and it's an internal router. So all we need to do right here is just do area 12 NSSA. That's the only router that needs this command. Now, the caveat to stubs is that the stub flag must be on the neighbor. So if you create one interface as a stub, you need to do the other interface on the other link, the other end, as a stub as well, or else you'll get what's called a stub mismatch. And then you're going to tear down the OSPF relationship if you put one interface as a stub and the other end of that same exact link. If you don't put that as a stub, you're going to tear down the OSPF relationship. So that's one. That is one parameter that has to match between OSPF neighbors to become a router. So let's go ahead and fire up Boson Netsim. Y'all know I've been liking that application so far to learn about these topics, and we'll go ahead and experiment with OSPF special area types. All right, so here's the lab we're going to be working with today. Route Lab, OSPF special area types. Here's the topology we're going to be working with. As you can see on the left-hand side, we got here, this is the cloud area 0, which is also known as what? Pause and think about it. The backbone area, right? This is the backbone area right here. On the left-hand side, we got area 2. Area 1 on the right-hand side, we got area 3 and 4 at the bottom, respectively. And then we have our external routers, A, B here, and C right here. So let's go ahead and see what we're working with here. This is our command summary, basic commands right here. The main one we really need to, but these are some show commands that we can use to look at the OSPF database, link state database, and which interfaces are running OSPF. We also have here, this is of all of the basic commands here, this is the one we really need to, we are going to be working with. Area ID, stub, and then these extra options right here, depending on whether we want to create a not so stubby area or a totally not so stubby area. This is the addressing guide. We can skip this part right here. This is all the interfaces and stuff like that. Task 1 says here to verify initial configurations. We'll go a little bit over that. We're going to skip the plan stub configurations because there's about 18 questions. I'm not going to go over it. This video will be so long, and I don't want to do that with y'all. We came here to really configure and verify OSPF stub areas. That's task 3. And also task 4, not so stubby areas. So we'll work with those two. Let's go ahead and start with some basic initial configs right here. It says here that this task involves OSPF initial configs. Verify the IP address and state of each interface on each core router. We don't have any unplugged cables. This is a network simulator, so I'm not going to do that with y'all. Each distribution switch, no, I'm not going to do that. And the backbone router. I'll go ahead and do the backbone router since that's like the main, that's like the core of the network, basically. Using the proper show command. The line and protocol of each of the configure interfaces on each router should be up. Was that layer 2 and layer 3. So let's go ahead and go to backbone router 1 and just check the interfaces on that. How you do that? Well, basically show IP OSPF, no, show IP interface brief. And as you can see here, we got several sub interfaces that are all up. We have a serial interface right here, and those are down. So that's basically it. I'm not going to check every single router for y'all. They also want us to verify that OSPF is configured to run properly on the backbone. How do we do that? We can do show IP OSPF. Well, we can start with show IP protocols. Let's start with that first. As you can see, we've got EIGRP is running here, EIGRP 100, and we also got OSPF 1, process number 1. And as you can see, another thing we can check is just OSPF. We do show IP. That shows all the protocols. We do show IP OSPF, and that's going to let us know whether OSPF is running properly or not. And as you can see, routing process is 1. This says it's an ASBR, so we get a lot of information here. We're redistributing EIGRP 100. That's probably from this router right here. It says here that it tells you where SPF has been recalculated in here as well. There it is. No, yeah. The SPF algorithm was executed 18 times. I ran this lab for a little bit while I was talking to my girlfriend and stuff like that. She was talking to me. And let's see here. We have in which area our core router 1 is located right here, and DSW1, so distribution switch 1, configured to run OSPF. Well, we can look by the topology and see that they are in area 1, but how do we do that in the command line? Let's go to core router 1 and see. We check the areas by doing what we just ran, show IP. We got to go into user exec mode or privileged exec mode, show IP OSPF, and we can see we have area 1, number of interfaces is 1. Area 0, number of interfaces is 1. And we can tell by just kind of looking at the map here. So we've got 1 in area 0, the interface, that interface right there, and 1 in area 1. So that confirms it, but that's just looking at the topology map. Any network you get hired onto and to work at, not everybody's going to have a mapped out, easily mapped out, well-drawn topology for you like this. So you need to know these commands so that way you know what interfaces, what areas they sit in and stuff like that. Let's go to distribution switch 1 and verify that. Enable show IP OSPF. And we can see here we've got one interface in, we've got 5 interfaces in area 1. And remember, this is a switch. And we've got, that's pretty much it. Nothing on the, nothing in area 0, right? Because if we look at this map here, we've got those 5, we've got several interfaces in area 1. And then this one, it just also sits in area 1. So we don't have one in the backbone. That distribution switch is not connected to the backbone. What's the next question here? They want us to do the same thing with the rest of these, and I'm not going to do that. So this, we can tell by the map which interfaces are in which area, right? So we'll skip that part. Verify that backbone router 1, backbone router 1 is right here, is redistributing EIGRP process 100 classical networks, which I think we did that. Let's go ahead and do that anyway. Show IP protocols. And it says here, and that distribution switch 3 is redistributing EIGRP 200, and distribution switch 4 is redistributing EIGRP 300. So backbone router 1, they want to know EIGRP 100. We did show IP OSPF, and we can see here, EIGRP 100 is, in fact, running on backbone router 1. Distribution switch 3 is located right here. We do show, enable show IP protocols, and we can see that it is running EIGRP 200, right here. Same thing with distribution switch 4, located right there. Enable show IP protocols, and you can see it is, in fact, EIGRP 300 is running on there. So I'm not going to do the rest of those guys. Well, we did all of them right there. From backbone router 1, which is located right here, they want us to ping each workstation in the network, and they should succeed, apparently. We've got 1, 2, 3, 4, 5, 6, 7 through 12 here. I'm not going to ping every single workstation. I know they work. We don't have any unplugged cables. Again, this is a network simulator, so I'm pretty sure they work. I don't want this video to run too long. We're going to skip task 2, plan stub configurations. There's a lot of, this is material you got to do to read on your own. I'm not going to make this video 2 hours long and answer 18 questions. So I thought about doing it, but it was going to run too long. Task 3, configure and verify OSPF stub areas. This is what we came to do, the meat and potatoes of this. This task involves configuring and verifying OSPF stub areas planned in task 2. Using the lab topology diagram above, list the ABRs in this lab. What's an ABR? It's an autonomous, no, I'm sorry, it's an area border router. So it's an area, it's a router that sits in between the borders of 2 areas, right? So really, it's not really the router. It's you have one interface in one area and another interface connected to the backbone. So, well, it could be one that sits between just 2 areas anyway. But anyways, let's look at the topology and you can see that. And I'll show y'all. So for example, core router 4 is an area border router because it borders area 4 and it also borders area 0. So it has an interface in area 0 and has an interface in area 4. Same thing with core router 3. He has an interface in area 3 and one interface in area 0, the backbone area. The other area border routers are core router 2, core router 1, and core router 3. You might be looking at this and thinking that should be 1, 2, right? No, it's an autonomous system boundary router, ASBR. We'll get further into that, I believe, in the next question or 2. Task 3, task 3, task 3. Issue the proper show command to verify the previous step. How do we verify that? We know the backbone router 1 is not 1. We know core router 1 is 1, right? So how do we verify that? Show IP, believe IP OSPF interface. Let's just do interface. Can't we just do all interfaces? Yeah, we'll do that and we'll see all interfaces. Nope, that's not the command we were looking for. It is actually show IP OSPF. And we can see here, you scroll up to the top, it is an area border router. So that answers that question. So I'll do one more. core router 4, enable show IP OSPF. Scroll to the top, and that's your answer right here. It is an area border router. Question 3. On distribution switch 1, let's go to distribution switch 1. Display the link state database. How do we do that? Pause and think about it. Show. We are back. Show IP OSPF keyword database. That is our database here. Use this output to answer the following questions. What LSAs will be removed after area 1 is configured to be a stub area? So let's look at the characteristics of a stub area before we answer that question. A stub area will filter type 5 LSAs. What's a type 5 LSA? It's an external route, right? So the link state database also contains internal routes, summary routes, and then injects a default route. Remember, we said that earlier in the video. So that's what happens when we configure a stub area. How do we configure it? Area number, and then stub. What LSAs will be added after area 1 is configured to be a stub area? I believe we know that we're going to inject a default route, right? So default route is technically an external route, right? So, I don't know, so I'm not going to front for y'all. Let's go ahead and look at the answers. 3B, task 3, 3B, and that's the link state database. I should have looked over that output for y'all. We'll do that in a second. Only a summary net type 3 LSA with link ID quad 0 and advertising router quad 1 will be added after an area is configured to be a stub area. So remember, we talked about the net LSA types in the last video. Summary net type 3. What is that? A type 3 is created by ABRs to advertise inter-area routes. What's an inter-area route? It's a route that's within our area. So when you think of, or I'm sorry, that's intra. Inter-area routes are routes. This is how I remember it. The word enter, I-N-T-E-R, it's entering our area. So we have routes that are entering our area, an external route like we just mentioned, and those are created by the ABR. So if you look at this right here, this ABR is creating a type 3 LSA, and that route enters area 0. Same thing with this one. He creates a type 3 LSA, and that route enters area 2. That's how I remember the difference between inter-area routes versus intra. Intra are routes that are originated from that area. And it consists of each subnet to reach it. Summarizes info from type 1 and type 2s. Why? Because type 1s and type 2s don't go into other areas, right? They stay within the area. Remember, we said that right here. They are flooded within the area. Type 2, flooded within the area. Type 1, flooded only within the area. And they are flooded into adjacent areas, as we've mentioned right here. Type 1 goes to the ABR, and then the ABR passes it along to the other ABRs, and that's how the type 3s are generated. So that answers that question. Let's go ahead and take a look at that database that I mentioned. Remember, we said in the last video, right? Show IP OSPF database. This is a type 1. This is a type 2. This is the type 3 that we just mentioned. Anyways, here's a type 4. And here's a type 5, not showing a type 7 yet because those are created with not so stubby areas, which we'll cover in a second. So question 4. On core router 1, let's go to core router 1 right here. And distribution switch 1, which is right next to it. Configure area 1 as a stub area. Do you remember how to do that? Pause and think about it. We're back. You should have hit pause. Configure terminal. You got to go to the routing process. So router OSPF 1. We got to say area. What area was this? Let's go and check again real quick. We have an interface. We have an interface in area 0 and an interface in area 1. So we want to do configure area. It says here configure area 1 as a stub area. So we got to do area 1. Area 1 stub. And that's basically how we do our stubs. Notice that OSPF bounced. And it says to do the same thing with distribution switch 1, right? And notice we're not putting the router in the area. We're putting the interface. It'll choose which interface. It says, okay, we have 2 interfaces, right? That's configured participating in OSPF. We have one in area 0, one in area 1. So when we did area 1, it's just going to put that interface or the interface in area 1 as a stub. So same thing with distribution switch 1. We'll do the same thing here. We're putting area 1 as a stub. So keep that in mind. And notice OSPF bounced as well. Actually, it's dead right here. Now we just tore down that neighbor relationship. Why? Let's go to our slides real quick. Remember we mentioned this? The stub flag must be on the neighbor. So that's why the neighbor relationship got torn down. If you're going to configure one area as a stub or one interface as a stub, you got to do the same thing on the other side, or you're going to tear down a neighbor relationship. And that's what just happened there. Let's go to global config mode and do the same thing. Enter a router OSPF 1 area 1 stub, and notice it the adjacency was forced to reset, and we should see OSPF come up. I believe it's up now. Let's double check. Do show IP OSPF neighbor, and there it is. I believe that's fast interface 1.1. So yeah, that should bring up the neighbor relationship between those two, because I don't think there's one. Should have two neighbors, I believe. Yeah, it should have two neighbors. There it is, right there. There it is, loading to full. So now we should have two neighbors. Nope. I don't believe the other guy's a neighbor. Anyway, on distribution switch 1, display the OSPF link state database. Compare this output to the output you received in step 3. Verify your answers to the questions in step 3. So we go to distribution switch 1. Let's get out of this. Show IP. I'm going to try to get this done before your boy goes on his live in a second. Dewan, I believe, goes live in about a half hour. So we want to try to get this done before then. Show IP database, show IP OSPF database, and there's the quad 0 we were looking for. Now it's now we got rid of our type 5s, as we mentioned. See, we also got rid of our type 4s, just as we mentioned here. Remember, we mentioned right here, we removed type 5s, and LSA type 4s are also removed. And let's look at let's look at the previous output. As you can see, there was the type 5s. We ran that command again, and now the type 5s are gone. On distribution switch 2, let's go to distribution switch 2. Display the OSPF link state database. Enable show IP OSPF. Use this output to answer the following questions. What LSAs will be removed after area 2 is configured to be a totally stubby area? Let's double check our slides. Totally stubby areas are similar to a stub area, but it will also filter type 3s as well. Technically allows a type 1 LSA for the default route. So remember, we inject the default route, which is technically an external route, but then we're going to remove our type 3 LSAs. And so it says here, as you can see, remove type 3, 4, and 5. LSA injects a default route into that totally stubby area. So, and this is how we configure it. Area number, stub, no summary. What LSAs will be added after an area 2 is configured to be a totally stubby area? I believe it'll add a type 3. No, actually, it's going to be an external route. So technically, I believe it'll add a type 3. Let's look at the answers and check. 6B. So task 3, 6B. A summary type 3, just like we said. Perfect. So let's go ahead. I believe it's going to ask us to configure it after that. On core 2 and DSW2, go to core 2, configure area 2 as a totally stubby area. Make sure you pay attention to which area you are putting the interfaces as a stub, or configuring as a stub. Interface, I'm sorry, go to routing process, OSPF1, and then you're going to say area, and then the area number, which is area 2. And we said as a totally stubby area, it is, I believe, area no summary, right? Stub no summary, rather. So stub no summary. That should cause OSPF to go down, as it did right there. On we got to do the same thing on distribution switch 2. So go to distribution switch 2. We may go over our time limit here. Router OSPF 1 area, we said area 2. Stub. What was the last keyword, Danielle? She don't know, y'all. No summary. No summary. And now notice it goes full to down on this side as well. Oh, it went full to down already, or just now. And that should cause OSPF to come back up in just a second once we start saying hello to each other. On distribution switch 2, go to back to distribution switch 2. Look at this, then no, OSPF is back. Loading to full. Compare this output to the output you received in step 6. We'll look at the link state database, show IP OSPF database. And notice let's look at our previous database. I don't think we ran the database earlier. We didn't do that. Oh well. Well, now we've got a type 1. We've got a type 2. We've got a type 3, and we don't have any 4s or 5s. So we removed our 3s as well, I believe. Oh, I'm sorry. We removed our 4s and 5s in this case. So I don't see what else we did here. But anyways, let's move on. Compare the output you received in step 3 with the output you received in step 5. Compare the output, compare the output, compare the output. Have the benefits of configuring stub and totally stub been achieved? I believe so. We probably made our link state database smaller because I didn't even double check. I should have done that before we ran that command so we could compare the database. Thought we did that, but we didn't. Okay, so now we are going to configure and verify OSPF not so stubby areas. What was Cisco thinking when they named these areas? Not so stubby. This task involves configuring and verifying OSPF NSSA's plan in task 2. Will Cisco iOS allow you to configure core 3, what's core 3 at? Right here, in area 3 as a stub, given that it is redistributing. Configure it as a stub, being that it's redistributing. Yes, it is. But you would have to configure it as a not so stubby because you're saying, okay, we want to redistribute. You're saying, I want to make this a stub, but I also want to redistribute routes. And that's where a not so stubby area comes in. So yes, it is allowed to do that. I think. Let's verify that. I don't want to steer y'all wrong. Task 4, question 1. Will not allow you to configure core 3 in area 3, being that is redistributing. So what do we need to do? I think that's why it would not. So I'm going too far ahead here. So it will if you make it a not so stubby area. That's what I meant to say. So not as a stub area, but when you make it a not so stubby area, then it'll allow you to redistribute. So I just didn't read the question right. I was thinking too far ahead here. So on distribution switch 3, go to distribution switch 3. Display the link state database. Use this output to answer the following questions. What LSAs will be removed after? Oh, that's why we didn't do that. I was looking right at the slides here. So show IP OSPF database. We have, let's see what we got here. We got a type 1, right? Network is type 2. Summaries are type 3. Summary nets are type 3. Summary ASBs are type 4s. Type 5 are AS externals. What will be removed after area 3 is configured to be an NSSA? So we said NSSAs, similar to a stub, but allows redistribution. See, that's why I got that question. I was thinking too far ahead as an ABR. Distributed routes will use a type 7, since type 5 LSAs are filtered. So since we're filtering type 5s, we're basically removing type 5. We're going to be generating type 7s. But then the ABR, I believe, or as the ASBR, will convert them into type 5s. No, maybe the ABR will configure them as type 5s. We'll change them to type 5s. How do we configure it? Area number, and then NSSA. So let's go ahead and do that. Well, I think that's the next question. No, next question is, what will be added after area 3 is configured to be an NSSA? One summary net type 3 with that link ID, and 4 type 7s will be added. So that's what's going to happen there after area 3 is configured to be an NSSA. So let's go ahead and do that. Core router 3 and distribution switch 3. Configure them as an NSSA. So we go to core router 3, enable, configure terminal, router OSPF 1. We're going to say area, what area was that? Area 3. Do you remember the keyword, Danielle? Do y'all remember it? NSSA. NSSA is the keyword there. So now OSPF went down, tore down neighbor relationship. Now we got to go to the other side, remember, because stub flags have to match. So we go to distribution switch 3, which is that guy next to it. Remember, we tore this relationship down. So we did that. We put this in as an NSSA, so we got to do the other interface as well. Configure terminal, router, OSPF 1, area 3. Do you remember the keyword, Danielle? NSSA, y'all. NSSA. Notice OSPF went down. Shortly, it should come back up. While it does that, let's look at the next question. On distribution switch 3, display the OSPF database. We're on distribution switch 3. Show database. And notice we have two type 1s. We have one. Let's go back. Let's run that command again. See, because OSPF came back up, as you can see. We have two type 3s or type 1s. We have one type 2, and we have several type 3 routes. And then right here we have added a type 7. 5 type 7s. On distribution switch 4, use this and output to answer the following questions. What LSAs will be removed after area 4 is configured to be an NSSA totally stubby area? Yes, NSSA totally stubby. Let's see what we said about that. Totally stubby, totally not so stubby area is similar to an NSSA, but auto filters type 3 routes minus default route. The link state database will include internal routes type 7 and a default route. So kind of misleading here, but that's what happens. You're just going to configure one side as a NSSA no summary, the other side is just NSSA, which we're going to do right now. And that's how you configure it. Area number, NSSA, no summary. But it can be used on all, as you can see right. What LSAs will be added? We just mentioned what will be added. On core router 4, on distribution switch 4, configure them as not so stubby, not so stubby area, totally stubby areas. Looks like we're almost done here. We got 2 more questions. Core router 4, and we'll be done right on time. So core router 4 is right here. We need to configure that as a not so stubby, totally stubby area. Go to global config mode, the routing process, OSPF 1. We're going to say, what did we say the way to do it is? We said area number, NSSA, and then no summary. So area, and then the area number was what? It says area 4, right? Because look, when we look at the topology right here real quick, this is area 4, as you can see, with that circle right there, right? NSSA, let's look at our options here. No summary. Do not send summary LSA into the NSSA. And that's what happens there. So no summary. That causes OSPF to get torn down. And then here we got to do the same thing on distribution switch 4, which is right next to him, right? So we did it on core router 4, the interface there. Now we got to do the other interface. Go to distribution switch 4, do the same thing. Global config mode, confa. I remember at my job, I tried to run this command. For those of y'all that I don't know, I work in a network operations center. Basically, we monitor the network, so we don't do really any kind of configuring. And I was just real curious to see what would happen. And I got this denied and basically got cock blocked, and I couldn't run that command. And it basically said I'm not allowed to do it. So one day when I become an engineer, we'll do that. I'll be able to do that. But anyways, notice how OSPF got torn down on this side as well. We go to the routing process, OSPF 1, and we say we'd say area. Oh, look, we have a duplicate ID here. Interesting. 1.4.11. Maybe because, did I put it as an area? Did we put the wrong area? We said area 4, right? So that's really interesting. Huh. Let's verify that. We said core, we did area 4. No summary. That's really interesting. And now we got a duplicate ID. Huh. We probably did something wrong here. Anyways, let's maybe we have to put the other side into the area. Area 4, NSSA, no summary. And now OSPF goes from down to down. So it's forced to reset the adjacency. Display the OSPF database on distribution switch 4, which we're on it right now. Hopefully it comes back up. I hope that gets rid of that message there. OSPF database. Yep, and now OSPF came back up. That's real interesting. I got to look at that to see why that happened. Let me go on the other router to make sure that we're not getting that. Yeah, we're not getting that error, that error anymore. I got to look at that. Maybe that was designed to happen. Not too sure. Compare this output with the output you received in step 5. So we've got, let's see, we've got our type 1s here. We got our type 2s here. We got our type 3s here. We got some type 7s here. And notice it got rid of the, looks like the type 4s and type 5s. So we got 1s, 2s, 3s, and we don't have any type 5s. Compare this output to the output you received in step 4. I don't remember running it before, but let's verify. I didn't run it on this guy, so we got to go check the core router 4. I didn't run it on that guy either. I guess we just went straight to the slides and forgot to run that command. Have the benefits of configuring NSSA and NSSA totally stub areas you described in the previous task been achieved? Well, let's look at the answer to see what they wanted us to achieve, because I was so into our slides. After comparing the output you received, you should observe the benefits described in the previous task as achieved. Well, the benefits was basically making our link state database smaller, because remember, when we get rid of some LSAs to be flooding in our network, we're essentially reducing the load on our CPU when we do that, because there's less CPUs. We're blocking specific link state advertisements to be flooded into area. That's all I got for y'all today. That is my YouTube channel right there, NetworkBruh. Please go ahead and subscribe, hit that notification bell right next to it so that way y'all know when I put these videos out. I'm trying to turn these videos as fast as I can before the deadline and before I even take this exam. That is my Twitter handle, @NetworkBruh. Please comment, like, subscribe to the network.